All right, stats. Welcome to your probability review homework set. Please title your pages that. Probability review homework set. Put a little stat 1300 there to be more collegiate. This is your review video. I'm going to tell you how to answer the questions. So I know your homework begins looking like this. Yes, I do want you to make a little table. Okay, if there's a table in the question, yes, I do want you to make the table. I'm sorry, you have 13 days to do it though. Okay, anything that is a part of the question, okay, including that top there, the following table represents, I do want you to write it all out. Thank you, thank you, thank you. All right, here's an example. That I'm giving you a bunch of examples that are pretty similar. Again, this is probability review. You have been taught all this. In fact, some of these questions are just same questions we've seen before, tweaked a little bit. But I mostly want to talk about what work I want to see. So consider the data shown in the table below, which represent the marital status of males and females 15 years or older in the United States. Last time we did the census, 2010. So marital status: never married, currently widowed, divorced, or separated. Males in millions, you're going to want to add that up. It's 117.8. Females in millions. So whether, like on number 1, notice how I give you a bunch of numbers, you're going to want to add them up. You might want to add up also, so these are the columns, males, females. You might want to add up the different rows. Up to you. In total, 242.2 million individuals 15 years or older in 2010. Determine the probability that a randomly selected U.S. resident 15 years or older, so that's anyone in here, is male. So what you're going to do is you're going to write a probability statement for everything. So probability of male. What's the probability of picking a male? Okay, that's how many males there are. This would require the entire population of 242.2 million people of 15 years of age or older. Okay, just going to show that itsy bitsy work, and there you go. That one's pretty easy. Determine the probability that a randomly selected U.S. resident 15 years or older, again, someone from here, is widowed. So what's the probability of finding someone widowed? Again, that's taking into account the denominator would be the whole population of 242.2. And who is widowed? I do want you to show me that it's 3 plus 11.4. Show that little bit of work. That's the probability. All right, round probability to 3 decimals. Determine the probability that a randomly selected U.S. resident 15 years or older is widowed or divorced. So probability, widowed or divorced. Now we already know it's 14.4 for widows from above, so you can just write that. And 10 million males divorced, 13.8 million females divorced. So that's how I'm getting 10 and 13.8. And there you go. I'm going to go through this whole question here. D, determine the probability that a randomly selected U.S. resident 15 years or older is male or widowed. So again, probability statement is probability male or widowed. Now, you'll notice, folks, that in the male, so males column, widowed is a row. You simply add up the males and add up the widows, and notice how I would be counting that 3 twice. I'd be over-counting. Okay, so the probability of male or widowed would be how many males you have, plus how many widowed individuals you have, minus their intersection, because again, you'd be counting 3 both. Now, you can also just add up all the males and then add the females that are widowed to it, because you already have the males that are widowed. But here's what I did. In keeping true to the definition here of the probability of A or B, it's the probability of, it's the, in this case, the number of A, okay, how many males you have, 117.8, plus how many folks that are widowed, 14.4, minus which you counted twice, which was at 3, and there it is, okay? We could handle that one differently in class. We probably in class just did this plus this, and you still get the 129.2 million as the numerator. Determine the probability randomly selected person 15 years or older is female. That's literally the conjugate of A. Probability female is female over the entire population. Okay. Now we get into a fun one. Given, that is conditional probability. Given that the randomly selected U.S. resident is male. Again, this is exactly how I want you to show the work. So show it like this. No losing the points. Given that they're male, determine the probability that they are married. The given is always the second part of the statement. Remember, this line down means given. I want to know the probability that they're married given that they are a male. Okay, so given that they're a male, what's the probability they're married? So my denominator would be all the males, 117.8. My numerator would be the married males. So given that they're male, what's the probability that they're married? Given that the randomly selected resident is widowed, given that they're widowed, widowed would be the denominator. What's the probability they are female? Determine the probability they are female. So what's the probability they're female given that they're widowed? So widowed is the denominator. There are that plus that, 14.4 million widowed individuals, and 11.4 of them are female. All right. That would be your probability. Okay, so that's a good one to talk about there. Then the next one I want to talk about. So notice you'll be doing 2 and 3. I'm going to do 5 with you here. I know you don't have to do 4 or 5, but it's going to help you a lot with 2 and 3. It's the same thing, just with different probabilities in there. You know that the probability of A or B, AUB, is equal to the probability of A plus probability of B minus the probability of A and B, minus the probability of their intersection. All right, A union B is A plus B minus their intersection. So, on 4 and 5, the probability of E is 0.25, the probability of F is 0.45. In 2 and 3, they change in each scenario. All right, find the probability of E and F. F is the and is the intersection, or is the union. Or, and. Okay. So, I do want you to write this statement on each one you do. Got plenty of time to do this. The probability of E or F is equal to the probability of E plus the probability of F minus the probability of E and F. Yes, do write that each time we do one of these problems. For you, it looks like 2 and 3. So, what do I know? I know the probability of E or F is 0.6. I know the probability of E is 0.25. I know the probability of F is 0.45. I need to know their intersection, so I just do that math. Remember, probabilities are never negative, okay? Probability of E and F, or E intersection F, is 0.10. That's how you do 2 and 3. Number 8. Suppose that E and F are 2 events, and the probability of their intersection is that, and the probability of E is that. What is the probability of F given E? So, the official way we would write that is the probability of any F given E is, first off, the denominator, E has to occur. So the denominator has to be the probability of E. And if I want F to occur, given that E also occurred, the numerator has to be their intersection. This is saying F and E are both happening. So the probability of F given E is their intersection divided by the probability of E. Okay? So, do write that for, looks like, your number 4 and your number 5. We'll talk about, 5 is a little different. We'll talk about that in a second. Write that statement first. So, the probability of F given E is the probability of their intersection, which, again, it doesn't matter if it's, the probability of E intersection F is the same thing as F intersection E. They're both occurring. Okay? Both events E and F are occurring. 0.60 divided by the probability of E. That's where the order does matter. E comes second, so that has to be the denominator. And that's 0.750. You got plenty of those notes. I'm thinking chapter 12 notes. Suppose that E and F are two events, and that's not a probability, but that's the number. So the number of times that we have an intersection of E and F, that's 8 or 380, and the number of E, so E is 925. What is the probability of F given E? So the probability of F given E would be the number of times their intersection occurs divided by the number of times E occurs. Okay, it's all about intersection over that second part. The number of times they both occur could be F intersection E. The order doesn't matter there. Definitely has to be E in the denominator. That would be 380 over 925, which is 411. All right, that's how you, looks like you'll do number 5 there. And I did number 12 because it looks like you're number 6. So again, suppose E and F are two events, and the probability of E is 0.8, and the probability of F given E is 0.4. What is the probability of E and F? So what's the probability of intersection? Again, that would be the formula. The probability of F given E is F and E's intersection divided by the probability of E. All right, what do I know? I know the probability of F given E is 0.40. I know the probability of E is 0.8. I do not know the probability of their intersection. All I do is cross multiply it. 0.8 times 0.4, boom, 0.32. I know we've done one of those before. It was probably on, again, chapter 10, 11, or 12. I forget, one of those. Not chapter 13, that was binomial. All right, this is a good one. This is conditional probability again for the month of June in the city of Chicago. 37% of the days are cloudy. Also in the month of June in the city of Chicago, 21% of the days are cloudy and rainy. What is the probability that a randomly selected day in June will be rainy given that it is cloudy? Or if it is cloudy. It doesn't say given, but it is a conditional probability statement. It has to be cloudy. So what's the probability it's going to be rainy given that it is cloudy? Yes, you have to write a probability statement for everything. That's going to be the probability that it's both rainy and cloudy divided by the probability it's cloudy. So the probability that it's both rainy and cloudy is at 0.210. The probability it's cloudy is that 0.37 and divide. There you go. 0.568. All right, so that is pretty similar there to your number 7. Very, very similar, I think. Again, you have your notes. One of you already submitted a lovely rough draft for this, so I know you can do it. Okay, number 8, I'm just describing. Number 8 is pretty much the one we have the defective parts. Remember, we say like company buys 50% of its defective parts from A, 40 from B, 10 from C. A has a defective rate of like 5%, B like 6%, C 7% or something like that. Find the probability that it's going to be defective, type of thing. Find the probability that it's defective given that it came from A. Or find the probability, given, that sort of thing. You guys know. I don't have the question right in front of me. Okay, anyway, we've done a bunch of those. Number 9, we've also done a lot. Joe DiMaggio, I think we used Stan Musial. Whatnot had a batting average of that. What is the probability he would get at least one hit in 5 official bats today? You've done this one so many times. Let X be a hit. Do you say that? What's the probability he gets one or more? This is a complement question. Number 10, one you're going to have to do with the probability that a male birth occurs is 0.51. What's the probability that a 5-child family will have at least 3 boys? If X is a boy, you want the probability that X is greater than or equal to 3, which is 3, 4, and 5. This is, you could do a binomial distribution, or you could, that's probably the best way to do it, binomial. Okay, 5 choose 3, 5 choose 4, 5 choose 5. Type of deal, yes. All right, 11 is basically like that first question I went over today. You guys can do that one. Yes, you do have to write. I'm sorry, write out that chart. You'll be all right. Write out the question. You have plenty of time. Okay, I'm going to end this video. Actually, I'm going to end it now, then I'll pick up the next video here. Yak Math Video, signing out.